Rick. So good evening, everyone. So we have Angular APAC meetup tonight, and today we have Tom who comes back to talk about Angular with D3. I'm so happy Tom is here because he was so nervous. Like in his first talk, I thought he would never come back, but he decided to come back 2 months later with a topic that I'm very interested in. So thank you, Tom. And it won't happen without two people. Um, the sponsor, um, AG Grid, and their founder Niall Crosby and Bonnie, who has this cozy platform for like everyone to gather together to learn from different Angular developers. So thank you, Bonnie, and thank you, Niall. So tomorrow we have another talk at Angular Europe. So Agent RR is going to talk about a topic that I also like, but I cannot attend because it's way too late in my local time. So he's going to talk about VS Code and why it is his favorite tool, which is also my favorite tool. I use it at work and at home. So that's everything that will happen this week. And I'm going to give the floor to Tom for him to show his lovely presentation.
Great. Okay. Thanks, Connie. I'm just going to share my screen here. Okay. You can see my screen.
Yes.
Yep. Okay. So I'm gonna cover kind of introduction to D3 today. So I'm gonna say D3 with Angular. The application you're looking at is an Angular application I developed. So you'll see throughout the talk there's elements of D3 within it. So I'll touch on some of the ways to profile your application when you're running D3 to ensure that you're not triggering lots of change detection cycles, etc. But mostly it will be focused on D3 itself. So I guess a little bit of background about myself. So I'm a senior front-end engineer, Angular and general web enthusiast. I currently work on developing a real-time analytics application, which is based using Angular and D3 for charts. I got into D3, I suppose, probably about 5-6 years ago. I was tasked with creating a kind of data visualization, which was essentially a timeline. So that was kind of how I kind of started my journey into D3. A slightly scary journey because it's D3 sometimes gets a reputation for being very complex. But like anything, if you start small and kind of ease your way into it, it's not too bad. But I found that out the hard way. So a little bit about D3 itself. So it's a JavaScript library. It's based on web standards. So it's not doing anything outside the realm of the web. I guess the one thing that it maybe is slightly unusual but central to D3 is that it uses SVG for drawing shapes in the DOM. It can also be used with Canvas, but that's not, generally speaking, it's mostly used with SVG. I guess the real power of D3 is the concept of taking data and binding that data to DOM elements or SVG elements. So if you have an array of objects, you can do a data binding. Basically means you can bind that data to different SVG shapes. So for example, you could have an array of people and attach them and create a circle shape to represent each person and use some of the attributes from the object to style that circle. So we'll kind of cover that a bit as I go on. So D3 itself comes as a single library, which has a lot in it. So depending on what you're doing, you can import the whole library. But in addition to that, it has a micro libraries concept, so you can just import various pieces of D3 that you actually need in your application. So some people would be just developing a data visualization, and they wouldn't really need to worry too much about the performance, so they might just pull in the whole library. But if you're developing it as part of an application and you're just doing some charts, you might need to only pull in one or maybe 2 to 3 micro libraries to use it. So again, this application you're looking at is it's up on my GitHub profile, so I'll have a link to it in the resources, so you can take a look at it as well after. So a little bit about SVG itself. So SVG is just it's an image format. I guess it's one of the, well, it's been around for I'd say at least 15 years or so. But it basically allows for scalable vector graphics. So it's quite nice, or compared to other image formats, you can actually manipulate, you can target parts of SVG via document.query selector to select, say, a part of the SVG image and change its color, or move it, etc. So it's a lot more powerful than just a static image, because you can actually interact it and change it depending on events. And it's an XML text. It's an XML text format. So I'll move on to the next slide. So just a little quote from Edward Tufte, who's one of the I guess old heads in terms of data visualization. He's got a kind of a book on data visualization, which is kind of like the data visualization Bible, maybe. So I've got a link to that in my resources as well. So he says, in good information visualization, there are no rules, no guidelines, no templates, no standard technologies, and no style books. You just do whatever it takes. Now, I suppose D3 is very powerful. Some people think of it in the context of charts, and it can certainly do charts, but it's not limited to charts by any means. So that's one of the reasons that some people choose to opt to use D3, is because you're not constrained by any particular implementation of a chart library necessarily. On the flip side, that obviously comes with the cost of having to learn D3. Okay, so I'll just move on to the next slide. So here we're just looking at the various SVG shapes that are available. So we have a rectangle, circle, ellipse, a path, polygon line, and a line. So each of these has its own different attributes depending on the shape. So, for example, the rectangle, you can provide an x coordinate or y coordinate. The ORX and the ORY are for the radius, so it's kind of similar to the border radius in CSS, that you can change or smooth the corners on the rectangle, and then the width and the height, or the path length. For a circle is less, it's like the CX and the CY, which are again just the X and Y coordinates, and R is just for the radius, so defining how big you want that circle to be. Ellipse attributes are similar to CX and the CY, and the radius X and radius Y. And then polygon, you can just provide points basically to draw a polygon. The polyline is similar, except it's for an open shape. The path is probably one of the most complex shapes because it has a D attribute, but that D attribute is made up of all these possibilities for move to, line to, cubic Bezier curve, quadratic Bezier curve, elliptical arc curve, and closed path. So that can get fairly complex. But D3 has functions that will allow you to basically calculate or draw or calculate these paths as you need them. And then the line is just a simple line, x to y, x to y, x to y.
Hey Tom, Laura
Yep.
asked if it is something that is used on dashboard.
Yeah, I mean, any of this could be used anywhere in a dashboard. Like, for example, for bar chart, which we'll look at later, bar charts use rectangle shapes, basically. So you basically you have to plot the rectangle with the x and y coordinates, and then, adjust the height and the width to match whatever data you're trying to display. So as we move on, we have a couple of examples of bar charts and how you can create bar charts with D3. But any of this can be created anywhere within the DOM. SVG itself can also be nested, so you could have an SVG element which hosts other SVG elements. So that can be useful because if you want, for example, if you have a bar chart with an x-axis and a y-axis, and you also wanted a label section or a legend, you could create the legend as a separate SVG element and have the chart itself as another SVG element, and host that all within another SVG element, which just kind of separates the concerns out of it. So I'll move on just to the selection, how you use D3 to do selections. Now, it's fairly similar to something like jQuery. I mean, essentially, you're just using the document.select and document.selectAll, or the query selector to get elements. So in this top left example here, I'm just making a selection for this grid element by ID. I'm selecting a tile, and then I'm just changing the style to a color, so it's got a few colors. So I can just run that and change the colors. On the right hand side here for the SVG transforms, SVG uses a different coordinate system to regular HTML. There's no box model, so things are slightly different. So in terms of how you do transforms or how you position elements, takes a little bit of getting used to, but essentially you need to provide coordinates for the elements where you want them to appear. So we have the translate X option. So all these options are similar to what's available in the CSS standards. So you can move up and down, and cause scale to reduce and rotate elements, and also skew elements. And then I suppose.
Hey Tom, can you zoom in a little bit? I guess we all want to see the code.
Yeah, sure.
Thank you.
Any better?
Perfect.
Okay. So then on the bottom left here, I just have an example of using a filter. So basically, similar to JavaScript itself, there's a filter function in D3 that allows you to filter out elements. So in this case, I'm just filtering out elements that are not green. I'm changing the color of the not green ones here. One thing we should mention, so we see this D3 select all G rect. So the G element in SVG is very important. It's a group element. So it's basically a way, if you have, say, for example, for a bar chart, if you had a group of bars that you wanted to associate or keep together, you would wrap them in a G element, and that way you can style them via the G element, and you can also change their position using the G element. So you'll see G used quite a lot in D3. And on the bottom right, in terms of selections, so anytime you call d3.select or select all, what you'll get back is a selection object. And on the right hand side, we just have a little snippet of what that looks like. So essentially it gives you back a group of elements, as you'd expect. And on where you see the two rectangles there at the bottom, that's just when you have a selection, you can also call a nodes function on that selection, and that will give you back the nodes related to the selection. And it obviously has the parent element there as well. So I'll move on to the data binding, which really is I guess is really the core concept of D3, because without it you wouldn't be doing anything with data. So basically, if you look at the left hand side here, the selections and binding. So I've got a very simple array, which is a number array. So we're doing a select on this card, and calling select all, and providing it a button keyword, and then this dot data is it's kind of where all the data binding magic happens. So it's essentially calling a set data on these elements, or rather, it's binding the data from this array to the two button elements. The dot enter. So in D3, there's a kind of concept, or I guess there's an analogy with the stage where you have data, and data enters the stage, and it can exit the stage, or it can change on the stage. So that's what the enter means there, is basically we have, in this case, we have new data, and we're calling enter, and that's gonna add it to the element, or make it visible essentially. And in the text area here, we basically by default in D3, when you have a text element or other shape elements, you'll get a callback called implicitly with the data. So in text, we have a callback, and it's just providing the data. So in this case, it's just the numbers 1, 2, 3, 4, 5. Now we look at over on the right hand side, where this is going to be an object, and we can actually call a particular property on an object. The enter function is still there, but D3 has updated so that there's a new syntax, which kind of is a bit of sugar, I suppose, to the old syntax, but it's probably less explicit in terms of what it does. So you can basically call dot join and pass it the shape you want to create, and that basically replaces calling dot enter and append. So it's just a bit more simple. But you probably, in the wild, you'll probably still see enter used in places. Okay. So then moving down to this bottom section, the bottom left here. So if I haven't done what I've done above, if I call select.card and select just a button and call .data on that button, it's basically saying get me the data for this element. So that's going to give me back the one here. And if I do a select all and call .data on that, it's going to give me back all the data bound to the elements I've selected. So D3 will basically add a data property to your elements, your SVG elements, and allow you to basically access that data whenever you need to. I suppose I should mention also, I mean, it's mostly used with SVG, but it's not. You can use it with HTML. There's no reason you can't use D3 with HTML, though. You know, there's obviously other libraries that kind of have that area covered. So just on the last selection down here. So when you make a selection, you also have the option to call a .node or .nodes on that selection, and that will basically give you back the elements that are part of that selection. So in this case, calling .nodes on this selection will give me back all the buttons. And you can see here there's the buttons drawn. So move into the center portion, which is more or less the same, although we're using a kitties array. So we're using objects where we have the name, age, and color of our kitties. And same as before, we're just making a selection. So we're calling select this SVG element. We're going to bind it to a circle, and we're calling .data with the kitties array. By convention in D3, you can provide a key function. And the key function is there, so D3 knows what key to use. If you're, well, I mean, generally speaking, you will be using an object, so you know, it will know what key to use for that particular object. So in this case, we're using the name key. So that means basically, if we were to come along and update mittens to change their color or something, the D3 would know that mittens refers to this particular element and how to update it. So then moving down to the bottom part here. So with the kitty selection, again, we're going to call that enter and append circle. Now for the fill, so we're calling fill, and our callback is going to give us the kitty object, and we're going to use the color that we've specified on our kitty. And for the CX, which is the X coordinate of the circle, we're going to use the age. I've just multiplied it by 25 here just to give a bit of difference between them. The CY is the same. They're all on the same y-axis, and the radius is 40 for each of them. I suppose one thing to bear in mind is that the SVG has slightly different property or attributes than CSS. So fill is the way you basically provide a background color, and there's other areas, like if you want to put a border on these circles, for example, it would be a stroke, and you know, there's various differences. But if anyone's used any UX tools or graphical tools like Figma or Photoshop or something, you'll probably be familiar with some of those. Okay, so moving over to the right-hand side, so we can enter data and add new data. On this side, we're just looking at what happens when the data changes and you want to remove something. So in this case, on the bottom, or sorry, in the middle selection here, I'm calling the .data, but I'm changing it to filter out kittens who are older than 3 or equal to 3. Now what that gives you is another selection. This selection we can call exit on it, and then remove, and that will take care of removing the kitty we wanted from the view. So again, I guess with selections, you will get back. You will have the option to enter, exit the various elements depending on what the data is. Yeah.
But Tom, why would you do that? Why not filter the array before you bind the data to the graph?
Well, so if you have a bar chart, say, and you want to filter out any, I mean, I suppose what you're saying, you could do that, but I guess D3 kind of handles it for you internally. So if you pass it an array, an initial array, and that array changes, and you pass that array back into D3, it will know what is bound to the elements, and it will know how to update or remove or alter the elements if you want to. Does that make sense?
Yeah,
so I mean,
maybe can be more interactive. Maybe user can make some criteria update, and then the graph reflect.
So one thing that's quite common would be to, if the data changes, is that you would do a transition on the data that has changed. So for example, if you had a bar chart with, say, four bars and one was changing or being removed, you could apply a transition to that bar to make it fade out or disappear. So I show an example of that a bit later on here. Okay. So I'll move on to talk a little bit about the various scales. So this is only a small subset of the scales that are available, but they're probably the most common ones you'll encounter. So basically, a scale is well, I mean, like if you have a map book and you have a country you need to fit on a page, you have to scale it accordingly to be able to fit it within the page. So in our case, the page is the viewport that we have to work with. So if you have an SVG element that is 500 pixels wide, and you have, say, a data array with 1,000 elements in it, you need a way to be able to scale or create a scale that will allow you to fit your content within that range. So looking at the scale linear, so D3 has a scale linear function. So here it's basically calling that function, and on that we're providing the domain. So the way I think of the domain is it's the kind of the data domain. So it's the way we the minimum and maximum points of the data that we have. So in this case, I'm just passing in a 0 and a 1,000. But if we had an array of objects with, say, people's ages, we'd calculate the minimum age in the array and the maximum age in the array, and we'd pass them into this domain here. And then the range is relating to the viewport that we have to work with. So in this case, I'm saying we have starting from 0 to 500 pixels to work with. So when you call that gives you back another function, which is called linear here. and then you can call that function with numbers within the domain, and it will give you back basically the scale for where they could be positioned. So if we call linear 0, I get back 0. If we call 500, I get back 250, or half of 500, and go back 1000, which is the top of the domain, I get back 500. In addition, there's also the option to invert the scale, so you can call it and get the reverse of the, so it's like swapping the domain for the range. So these scales are used to basically position things, or position your data. So if looking down to the middle section here, so I'm doing a data bind with an array of numbers, and just creating rectangles for those. And then for the x coordinate, I'm just calling the linear function we created above with the number. So for each of these numbers, we'll call linear, and it will give us a scale within the range that we can use. So you can see the blue rectangles here are kind of positioned according to that scale. And on the bottom here, it's a similar idea, but we're using the x and the y scale also. So you can see the kind of step effect because we've added the y. And then I guess there's the scale ordinal, which is probably maybe a little bit, it's, well, I tend to think of it like a one-to-one mapping. It's not quite, but in this scenario, we've got a names array and a colors array. So for the domain, we're just passing in the names, and for the range, we're just passing in an array of colors. D3 does have the option that you could pass in red and just blue, and it has a way to basically calculate the range between red and blue, and it would give you points between red and blue also. But so that's shown kind of here with the red, green. So then using that here, I can just call select all, pass in the names, and just change the background color to use the scale that we've provided. And the text is obviously just going to be the name of the person. So D3 has quite a lot of inbuilt capabilities and kind of color schemes that you can use. So there's definitely a lot more you can dig into there. And moving on onto the right side, so we've got a time scale. So one thing D3 can be used for is like timelines, etc. So you can pass in an array of dates and call this scale time function. So we're setting the domain as the dates, and the range again to be 0, 500, and then with that you can call the time scale function, and it will again give you back coordinates for that for the date that you call. So on the bottom right here, you can see we've basically using that time scale to position these three circles down here at the bottom. Okay. So I'll actually might be a little bit tight for time, so I'm going to pass on. So I guess what I'm building up to is showing how to construct a bar chart using D3. So to do that, we need to first know how to create axes. So here we're basically looking at how that's done. So again, we're going to need a scale. So scale linear in this case. And D3 has an inbuilt functions for creating axes for left, right, top, and bottom. So what we need to pass into that axis left is the scale that we want to use. And then we can define how many ticks we want to have on that axis. So a tick means any kind of marker on the axis, so the 0, the 200, and the 400. And then I'm calling a translate on that just to position the axis. So in this case, the translate is the x coordinate is 35 across and the y is 30 down. And then I'm calling or invoking that axis here by this .co-left. On the right hand, for the right axis, it's the same thing, except just using .right or calling right. So the x-axis, sorry, in the middle, so we've got the line horizontal, and so we've got the line horizontal is our scale, same scale as we had on the left hand side. The only difference is we're just calling it axis top and axis bottom, and that will basically create axes on the top or bottom. And then on the right hand side, it's the same idea, except we're using a time scale. So at the top here, we're just creating a time scale. And then again, we're just calling axis left or axis right with the scale that we've created. So this, it takes a bit of getting your head around and a bit of experimentation to kind of get comfortable with it. And I'll show you a few places that will help with that shortly as well. So we'll just move on to the bar charts. So how do we draw a bar chart? So first, we're going to use this scale band, which is basically just another inbuilt D3 scale, and that helps with basically creating these bars and positioning them or providing the width for them. And then in addition to that, we're going to need the scale linear, which is going to be used for the axis bottom. And then to actually draw the bars, we're going to make a selection. So we're doing a select all rect, and we're doing our data bind with the data. So we just have an array which is people with just a name and an age. So we're binding that data and creating a rectangle for each person. And then for each of those, we're going to call our X scale to position that person. The X of bandwidth is just a way to define the width of the rectangle, which is an inbuilt D3 function. And the Y is just how we position each rectangle. So in this case, we're using the Y scale with the d.age minus the height. And the height we are calculating by calling the Y scale with the user's age. And so we can see for the various users, they'll have different ages, which then we're just providing a fill for the bars or the rectangles. So in the middle here, it's more or less the same, except we've added some event handling. So there's a mouse over event and a click handler. So on the mouse over, you can basically a function will get invoked, and the convention in D3 is when that's called, you will get a reference to the element, which is why we're calling select this. So when I mouse over a bar, I'm going to get that element, and I can change its fill to red. So we can see that happen here. And then when I mouse out, I'm doing the same thing except changing the color to green. And then when I click on an element, I'm calling this a transition, which basically means I'm going to change the bar's height to 0 and y to 200. So effectively it's going to disappear. So you can do that for all these guys. I guess that's kind of some of the interactivity that you can get with D3. On the right hand side, it's similar again, creating the bars, but this time we're just adding the text to the actual rectangle itself. So in this case, I'm creating a group element. So we do the data bind with the step data, but rather than appending a rectangle, we're appending a group element. And then for that group element, I want to add a rectangle to each group, but I also want to add text to the group. So that's why we can basically get this this text added to each of the bars. I'm a little bit conscious I'm simply running out of time. I thought this would be quicker, but so moving on. So this is basically another bar chart. This data is actually being pulled in from GitHub. So GitHub is a public API where you can pull users' information or some user information. So I'm using that to just pull in a limited set of data here. And I think it's the login ID. They don't have. I was looking for some good way to calculate the height of the bars. So they didn't have anything like age or number of followers exposed. So I think I'll just use the login ID to create the bars. So with this, I've got just a couple of examples of ways to filter. So again, you can filter by age or and you can rotate. Obviously, you can all that kind of stuff. You can make it wiggle, and these are just applying transforms behind the scenes. I think empty just makes everything disappear. And there's a zoom functionality. So because it's SVG, you can freely change the the zoom of the actual SVG element itself, and it will stay. It will be lossless in terms of how it's displayed, I guess. So I can still do that. And it's just a sort. As I said, all this will be up in my my GitHub repo. So if you wanna take a look and poke around there, you can do that. So I've just got a few links. So I've only got a few minutes, so I'll just go quickly. So this is just a simple, well, it's actually probably quite a complex D3 visualization. It's kind of one of the ones I used as inspiration for the first timeline I worked on. So basically, it allows you to zoom in and out of commits to GitHub and see who made those commits. This is it's a tool called Coggle, which I've been using for creating mind maps. This is all SVG. I can't be sure if it was generated using D3, but I would imagine it probably was. But basically, this is an Angular kind of mind map, which I've been working on in the background, trying to get my head around all the various parts of the Angular ecosystem, I suppose. So it's still a draft, but there's a fair bit in there. So on this is linked in the resources here also, so you can find it there, and feel free to fork it, or if you want to help make it better, I'll get to that as well. When you're looking around at D3 examples, there's a lot of examples out there. Observablehq is one of the places that you'll find probably most examples, and so it's got great resources for anything you want to do with data visualization or D3. There's actually a Learn D3 written by the guy who created D3, Mike Bostock, also. So that's from the horse's mouth, as it were. So that was definitely worth a look. And you probably come across these these blocks as well, so bl.ocs.org, which is kind of the predecessor to observablehq. So these blocks generally show you the visualization, and then below it they would show you the code that was used to create the visualization, plus the data. So generally, if you're getting started, you might use something like this to kind of copy and see if you can get this working within your application, and then adapt it to what you needed to do. But the same thing is here, but this is a slightly different format. So it's essentially a live notebook, so you can click on parts of it and see the code that was used to create the visualizations, and you can type and update the code as well, and run it and see the changes. Although it's a little bit trickier, or it used to be a little bit trickier to actually use this code in your visualizations, because it's kind of packaged up slightly differently. Okay, so this is just the D3 repo itself. As I mentioned, you can pull in the whole library, or you can pull in micro libraries. So this link is in the resources. It shows you all the various micro libraries that are available for D3. So there's quite a few of them. And this is another article by Mike Bostock, who created D3, about how selections work. So I definitely, if you're interested, I definitely recommend trying to go through this. And in terms of SVG, Sarah Sweden is the authority on SVG. She's got a lot of great resources here, all about SVG, and there's a lot more to it than I've talked about, but it's definitely worth a look if you're interested. I think we're nearly out of time, so I better stop and see if anyone has any questions.
Awesome. Very good. Can you hear me clapping?
I can.
Awesome.
I've scared everyone from using D3 yet. It's definitely a journey, but I think it's definitely, if you're interested in the area, it's definitely worth the effort, I think.
Yeah. No, it's great. The demo is cool. I mean, the app that you use to demo the code is also cool. You need to open source it, Tom.
Oh yeah, that's it is. It's on my GitHub repo. I think it is linked in the resources, so you should be able to. Or actually, this app itself. Yeah. So the code for this, I'm just trying to see if I've updated I haven't included. I'll put the link in for this application, which is hosted on Firebase.
I see. Because
and I forgot to add my GitHub thing, which will have the link to the source for this application also, so you can see all the examples.
it's great because like there's this like data visualization expert like Shelley Wu, and she uses React to teach the concept of D3. So I'm very happy that you decide to talk about D3, but in the context of Angular. So to show people that Angular can also use as D3, and don't switch to another library, because like some famous like engineer like uses that one to do visualization work.
Oh no, sorry, one thing I meant to mention was if you're using D3 in Angular, you have the option to use the zone to run outside of Angular, so you can use the ng zone to run outside of Angular, so you won't be triggering change detection for your charts necessarily if you don't want to, which you probably don't. Well, I was going to quickly show that. I'll try just a second. So on this application, I think, yeah, so on the middle chart, I'm running, I haven't done anything, I haven't changed anything, so you can see all the change detection cycles being triggered. But on the right-hand side, I'm running outside of Angular, so it's not triggering any change detection. So that's kind of how you would, avoid, any potential performance issues with running in Angular. Okay.
It's awesome presentation. Thank you, Tom.
Great. Well, thanks everyone.
Yeah. So, does anyone have any question? I guess most of the people had dropped off. But it's great. Thank you for coming to show us this cool library.
Mm-hmm. Yep,
Yeah.
no problem.
So
Right.
so if so if no one has any question, I want to say thank you very much. If you decide to talk about D3 round 2 or you have other topic that you want to present, you are always welcome back to Angular APAC. Tom, you're like the VIP.
Well, thank you very much. I'll
Yeah,
take it from that offer. Right.
so I guess this is the end of the meetup. The next one is March. So I guess I will see you guys in March for another interesting topic by another interesting speaker. So thank you so much, Tom.
Okay, that's
So
great. Thanks,
let
guys.
me stop the recording. Yeah.
Thanks, Tom. Nice presentation, man.